Two masterminds from the Kumasi Technical University are making waves with their innovations and inventions. One has developed a smart smoke detector system that automatically shuts down the load of an entire building just by getting in contact with smoke. And the other has built a home automation system backed by maximum security. This is what we bring you on R&D Africa in this episode. My name is Mamiekwa Otuakwa Nyame. Stay with me. So I'm currently with the two mastermind behind the smart smoke detector system and then the home automation system. And so Kujo is going to take us through his smart smoke detector system. He's going to take us through the process and also give us some demonstration. And when he is done, Stephen is also going to do that for us.
I just completed Kumasi Technical University. I did HND, Electrical and Electronics Engineering. I'm the brain behind the design and construction of smart smoke detector. The smart smoke detector system is a control board with a smart detector system which cuts out the power in a building after the smoke detector system has detected smoke in a building or house. My main motivation on this particular project is that there's a lot of fire alarm system in the market. So I try to build something unique upon it to make it more beneficial and useful in the community. So I try to come out with smoke detector system which will cut out the power in the building or in house after the system has detected smoke or flame. So my main motivation is to bring the fire under control after it has detected the smoke. So even before the fire personnel come in, the issue has been already bring under control, and it provides more security and safety. That's my main motivation on this particular project. This is the smart smoke detector system. Okay. And on this board, you see a lot of things, but on my left, these are normal switches and sockets we see in our homes. Okay. But my project is mainly based on this one, which is the smoke detector system, which contains the gas smoke detector system. Okay. It can also detect for gas, but I use it as smoke detector. Okay. And it's connected to the microcontroller. Okay. And it can also be called Arduino. Can also be called? Arduino. Okay. But we normally call it microcontroller because it controls.
And now that you've established what exactly you did on this board, can you take us through the process of making your smoke detector?
Okay. The smoke detector was built or made up with a smoke detector or a smoke sensor and Arduino board. And there's some basic components which were used. Okay. These are resistors and diodes. And the Arduino was programmed to 41%. So after the smoke has reached 40 or above 41%, the system will shut down. So the smoke detector was built in connection with this is the smoke sensor. Okay. And was built in connection with the Arduino. So after the smoke sensor has detected the smoke, it will communicate with the microcontroller or the Arduino to shut down the system.
Okay, so it is a communication between the Arduino and then the
smoke
here.
sensor.
That is how come when the smoke gets into contact with.
Yeah, after it has reached its maximum, the maximum was set to 40%. So any percentage above 40, it will shut down.
Okay, Kujo, so I think you can take us through the process. I want to see how the smoke communicates with the device.
Okay, sure. All right. The system will need smoke to function, so I would like to have a matches and a paper to produce smoke.
Okay, sure, certainly.
Okay. Now the system is on, and the smoke has been set to 40%. So when the smoke level is above 40, it will shut down the system. Let's try. That's it.
So I would like to try it again. I like
sure.
the feeling.
All right, sure, you can.
Okay, this is good.
Yeah,
this is good. This is
so
quite
that's
good.
how it
and it responds very fast because this is just a little bit of smoke.
Yeah, the sensor is very sensitive, that's why. The support I would like to see from any organization or university will be research, because I want to further this particular project, and it must require a lot of research, and financial to be another form of support I will need. Since I want to make this commercial, I will need financial support too.
A lot of people today in Ghana and around the world are having Android and smart devices, and we buy these devices at expensive prices. But I believe with the current trend of technology, we could make these devices work the more for us. For example, you've traveled and you want the lights in your houses to come on in the evening. You could use these devices to control them. You are in the house, you are busy inside, you want to turn on the outside lights and the lamps. You could do that. And other loads that you may not be able to rate them physically, but you want to use your Android devices to turn them on or control them. And to the extreme part, we could even know the energy consumption and the states of these loads within the house. So that's what these systems are all about, controlling and also monitoring our loads. With the first version, the version 1 that have been developed, it works using a local area network. That means you have to be within the Wi-Fi proximity of the controller, like around your house or inside the house, to control these loads. And the next version that we are building on, which I've also made the setup here, is supposed to then communicate over the internet. So over the internet, that is when we would use data to access it. The difference between this one and the ones people are having is a lot of people try to do this, but they use third-party apps. Like when you take companies like Amazon and Google, they are also having their own that they are actually selling out to people. But our own, we are developing our own app. We are not using a third party's app, but the app is developed from scratch on campus here by myself, so that we can also in the future trend have this kind of resource where other people or other countries could even host on our service in the future to come. So since we are developing the app locally, it means that the app can be customized to take the number of loads that the user has. So for example, if the user is having, let's say, 10 lamps and then 16 sockets, for example, in the house, then the app can be customized to be able to control all those loads simultaneously. So you can control these loads from your app. People who are not given authorized access to access certain things through the app, the password protected security can restrict them from accessing them, and can also help with parental control of certain loads. As you can see, these are the LED bulbs we've been using in our houses. And then these are sockets that we have been having in our houses.
Okay.
And these are to simulate a home environment. That is your home where you're having your bulbs and then your sockets you want to control.
Okay.
And then we have a circuit breaker here to allow or stop power to the whole system as we have in our homes.
Okay.
But what we don't have in our homes is this keypad with this special circuit breaker in which the microcontroller for the password section is actually embedded.
Okay, so these are what you built.
Very good.
Okay.
And then we have a microcontroller also here, which has a device that can help us to connect our phone to this system so we can control it with the application.
Okay.
So these two microcontrollers and that special access point device are helping us control these normal loads we see in our house without actually flipping the everyday switches we have been seeing.
Okay. Yeah. Okay. So can you take us through the process of building?
Okay. So this project can be grouped into two sections, the control section. And with the control section, we have the microcontrollers and also the Wi-Fi access points.
Okay.
As I said, the Wi-Fi access point is here, one of the microcontrollers is here, the other one is here. And then we have the power side where you do the electrical wire connections for these loads, the sockets, and then the bulbs.
Okay. Okay. So I think we can have a demonstration session, but I'm guessing you need your phone to do that, right?
Yes, please. So on my phone, we have the KsTU load management app.
Okay.
Very good. Okay. And then that's why we have the school logo there because I work in the institution.
Okay.
And also on this application, as I explained earlier, there is our own customized application. So we've made it to handle 3 loads in this section. That's why you can see the on-off there. So if let's say I want to turn the first lamp on from the application, I can use the on and then the lamp can be controlled.
I can see that when you did it, it responded in a matter of seconds.
In a matter of seconds, I can quickly turn it off without any delay.
Okay.
One advantage of this system over using GSM system is GSM system, someone have to type on, send it over SMS, and it have to take time till it is received and then the light will come on. But with this, we can have a faster response from the loads. And so you can also try to put the second lamp on using different lamp 2.
Yeah, lamp 2 control.
Yeah.
Okay.
And then that lamp can also be off with the off symbol there.
Okay. On, off, on, off, on.
You see the third load is connected to the socket. And I said that for controlling our devices over the internet and using our phones, bringing all this technology, there should be security. So I'm going to try and turn on these loads which are connected through the password protected layer. And you can see that if I try to turn it on, this lamp actually didn't come on. But the password system has now reacted. That, and it's saying that security switch, you want to activate, you want to change the code. So let's say you are the daddy or you are the mommy, sorry, in this instance. You are the mommy, and then you don't want your wall to turn off, let's say, the microwave or the oven. Now when the person tries to turn it on, the person has to go through the activation process before that load comes on.
And that is a code that you can set for yourself? Yes, please.
And then the change code gives you the option to change the code at your own convenience. So here we use only numbers for the password, so it's like you enter a PIN and then you have access to it. So for example, you say that if you want to activate these loads, press star. So if you press star, maybe I can give you the honor of entering there.
Certainly.
Okay, so
my favorite part.
Right now the PIN is 1,
1,
9, 1 again, 9, 5, 3, then D to activate before those loads are activated. So without the password authorization, these loads cannot be turned on either remotely or when someone is there.
Okay. I think I would want to know if you can control the password using the app, because assuming you would want to do that, but then you're not close to your house, and so you'd have to rely on your phone. Is that possible?
Okay, so for this version of the app, that is not possible. That's not possible for this version, but as I said earlier, we are trying to improve upon the home automation system to also get feedback from the loads so that we can do load management, and this feature can also be incorporated within that when possible. Yeah.
Okay. And so aside this, are you working on any other innovation aside but trying to improve this one?
Okay, right. I'm also having an innovation in the pipeline, which has not been constructed yet. Yes, and it is a rain harvesting system for farmers. You see that certain crops don't need to have too much rain upon them because usually the rain will wash away some nutrients called erosion in the farmland, and sometimes too heavy rains will beat these crops and then they will get damaged. So the idea is to have a kind of system that when it starts raining, it will allow some of the rainfall to soak into the soil, and when the soil becomes moist to a level, it will activate itself to collect the excess rain, which would have washed the nutrients away and destroy the crops into a reservoir, which can later be used for irrigating the farm. So that is an idea that I also have. When there is a chance to collaborate with any institution, I don't stand as the only one to gain benefit from this project, but other organizations can also benefit much from the project in the aspect of even mass production of these projects to be installed in facilities. There are a lot of houses being built yearly within the country, and as people see this as a new trend in house wiring, these organizations stand a chance of also being able to meet the production needs of these consumers. I have the will and the aim for these systems to be installed in a lot of houses that are being built within the country. And before this can be possible, I would firstly need the support in building the second version of the system, which is supposed to give the user remote access to his loads. And also, this will include having support for proper packaging and also installation of the system.
So I would want to find out if it's possible to integrate all the two into just one circuit or device or board. Is it possible to do that?
It's actually possible for that to be done, and that will just be based on us researching to select the right microprocessor that can handle the codes that are being used to control the various systems. So this can actually be done, and I think integrating these controls into the house, adding the fire security to the control would actually make it more robust and more reliable so consumers can trust such a system. So it is possible, and that would be the right way to also commercialize such a home automation system.
Okay. Thank you very much to my two gentlemen once again. And as you can see, viewers, my voice is amplified. I mean, that is what happens when you're speaking to inventors and innovators. You need to calm down for them to come up. This is where we end this episode on R&D Africa. So as usual, as I say, if you are an innovator or an inventor out there, do contact AAU TV and we'll be at your doorstep. This is the only show that projects innovators and inventors in the world. My name is Mamiukwa Utuakwa Nyame. Until next time, it's a wrap.